Alright, so we're going around the x-axis, or something that looks like the x-axis, so we want our equation set to be y equals, which we have, so we're set. Then you want to draw in your radii, because your volume is the outer radius squared minus the inner radius squared. So to draw your radii, you start at that axis of rotation, and you draw up until you hit something. And then that's some sort of radius, because when these are coming around, they're making radii, and that would in this case be the outer radius, because you can't hit any more, you can't go any farther, so there's just one radius, there is no hole in this thing. That's it. That's your one radius. So there is no inner unless you want to count 0 as the inner. And it's just pi times that radius, the cosine of x, squared dx, all in terms of x, so your limits are in terms of x from pi fourths to pi halves. And then you just solve this. We got the setup. Fortunately, the square root and the square cancel each other out, making it easy to take an antiderivative. Derivative of sine is cosine, so that's checking out. All we got to do now is plug in the pi halves and subtract what we get when we put in the pi fourths. So the sine of pi halves is 1, and the sine of pi fourths is root 2 over 2. And there's not a whole lot we can do with that. So we check to see if the book agrees. And this was that. And I lost my pi, because remember it's pi times the radius squared for the area of those circles that are going around. So just put that pi back in. I always forget that, but that's the answer.